Okay, we're going to finish up distributive property, so our second day on 2.5. And before we get into your note-taking guide, the first thing I want to do is just a little bit of a review of yesterday, but just pose one quick question. What if I gave you something like this? All the ones we did yesterday were like this. 3 times maybe the quantity x plus 2. What would that give you? 3x plus 6. Good. You give the 3 to the x, 3x. 3 to the 2, you got 6. But what if I changed it up and I went 3 times the quantity, x plus 2y plus 3z minus 10. Does the distributive property still apply?
Yes. Yeah.
Why?
Because they still multiply every run by 3, so they still have to.
No, think of it like a bag of groceries, right? This is just a little bag of groceries. It's only got 2 things. It's got an X and a 2. This is a big bag of groceries. There's a whole bunch of them. But how many bags do I have?
No.
I've got 3 bags. So I've got 3 of every one of these things in each bag. So I've got, who thinks they could distribute that thing for me? Give me one term. Stuart, give me the first term.
3x.
3x, because 3 times x is 3x. Second term.
6y.
6y. Jansen.
9z.
9z. Taishana. Excellent. Okay, so it works even though we might have more than 2 terms. All right, good. So today our focus is going to be on simplifying expressions. Now they don't have a spot to fill in your note-taking guide, so in the column where it says your notes, why don't you jot this down quick. When they ask us to simplify an expression, we want to use the distributive property first if we can. And then we want to combine like terms. Like terms was one of our vocab words yesterday. We said the variable has to be exactly alike. It's like apples and oranges. You can't combine them. You can only combine things that look exactly alike. So here's my algebraic fruit expression. I've got 3 bags. In each bag I've got an orange and a $5 bill. Okay. Then I find in my pocket, well, I guess I wouldn't find 6 oranges, but I've got 6 oranges already at home. Write an expression for everything that I have. How would you use the distributive property here? Essentially, what would you have?
7 orange plus 15.
Let's use, well, not quite. Let's use the distributive property first, okay? If I've got 3 bags of an orange and a $5 bill in that bag, what total do I have in the bag? Or in all my bags, what do I have, Taishana?
3 orange.
You've got 3 oranges, right?
Yeah.
So I've got 1, 2, 3 oranges, and I've got 15 bucks?
Yeah.
And then at home, I've got 6 oranges. 3, 4, 5, 6. Well, if I put everything that I have together, what do I have? If I put everything together, what do I have? Julia?
9 oranges and 15 cents.
Yeah, you've got 1, 2, 3, 4, 5, 6, 7, 8, 9 oranges. And I've got 15 bucks. Can I combine those 2 things? Oranges are way different than dollars. I can't combine them. But if things look alike, then I can combine them. What's that?
I wish oranges looked like dollars.
Okay. So how would you simplify this expression then? Again, it's not in your note-taking guide. Let's just talk about it. You got 6 plus 10x plus 3. What are your like terms up there? Which ones can we combine? Shower power.
6 and 3.
Hey, my numbers I can always combine. They're like terms. So how would this expression simplify?
9 plus 10x.
9 plus 10x. And just kind of a little mathematical thing, a little being a good mathematician, we want to get in the habit of always writing our variables first and any constant terms last. So how could you rewrite that, Shower?
10x plus 9.
Yeah, we could use the commutative property of addition to just flip the order, okay? And if we had multiple variables, let's say we had x's and y's and z's, we just put them in alphabetical order. We'd put our x's and then our y's and then our z's. Maybe I've got an example like that, I don't know. All right, how about this one? Who can help me out with this? 2 times the quantity 3x plus 1 plus 4x. Stanky, what do you got?
We do 2 times 3x, which is 6x.
I like it.
And then 2 times 1, which is 1.
Oh, careful. 2 times 1 is?
2.
2. And then you got plus 4x at the end. So what are the like terms up there?
6x and 4x.
So what can you do with those two terms? Makes
10x
10 x's.
plus 2.
And we can't forget about our plus 2. And we're set, okay? How about this one though? Similar, but a little different. 9 minus 2 times the quantity x minus 4. What do we have to do there? Ken, what do you think?
Negative 2 times x plus negative 2x.
Now how come you did times first instead of minus? Yeah, and GEMDAS tells us what? We have to, before we worry about this 9, okay, combining 9 with stuff, we've got to multiply stuff first. Very good. Okay, so you said you've got negative 2 times x, which is
Negative 2x.
negative 2x. Good. What else do you have to do?
Negative 2 times negative.
And notice he's calling it negative 2. That's very good because a number's value is determined by the symbol in front of it. So I ignore this. It's negative 2 times x, and negative 2 times negative 4 gives you a positive 8. And then what did you have out front that you can't forget about?
9.
The 9. So you've got 9 minus 2x plus 8. What can you combine?
9, 8,
Makes
1,
9 plus 8 makes
17.
17. And I can't forget about I might write it like that, but again, we like to try to put the variables first, so how could I rewrite that?
2x minus 17.
Anybody want to challenge them on that? Are those two things the same? What do you think, Taishana?
Negative 2x plus 7.
Yeah, we have to always keep the value with the symbol with the number. The negative is attached to the 2, so we got to keep the negative there. If I don't have a number, or if I don't have a symbol, what is implied? Positive, so it'll be plus 17. Okay? All right. You guys try this one in your note-taking guide, just in the margin there, where it says your notes. See if you can crank this one out. Again, common mistake, people like to multiply by the 2, but that's not what's getting multiplied. You've got 2x minus, we don't see it, but there's a 1 there, okay? We got 2x minus 1 times this group of stuff. So you got that 2x, okay, it's just there. But now I've got to take minus 1 times this group. So I've got to take minus 1 times this and minus 1 times this. Well, what's negative 1 times 7x?
Negative 7.
Negative 7x. Just do your numbers. Negative 1 times 7 is negative 7. Tack on the x. What's negative 1 times positive 4? Negative 4. Now I combine like terms. They make
Negative 5.
negative 5x's minus 4. Okay. And you don't have to draw the 1. After you do these enough times, you just kind of go, okay, I've got to give the negative to each thing inside. Negative 7x, negative 4. All right, let's try one more here. Find the perimeter and the area of the rectangle. Okay, let's start with just perimeter. And the one hint I'll give you, what's unique about a rectangle? 2 sides are the same. So if you know this is 8 minus 12w, what can you tell me about up here? 8 minus 12w. And if this side is 9, what can you tell me about this side? Let's take a second, see if you can come up with the perimeter of that rectangle. When you find the perimeter of a figure, okay, when you find the perimeter of a figure, what are you essentially doing? Kayan?
Dividing the length around it.
Find the length around it. It's like walk around. And so if I started right here at this bottom corner, let's just say I went up. Okay, well I go 9. And then go in this direction, I go plus 8 minus 12w plus 9. Plus the last side is 8 minus 12w. If I combine like terms, if we just look at our w's, negative 12w and negative 12w makes negative 24w. And I saw some people put squared. Okay, it's a common mistake. But why don't I have squareds? Why don't I put negative 24w squared? Taishana?
But the two aren't multiplying, okay?
Yeah, if it was W times a W, that's when we get a W squared. But we're just combining walruses and walruses. I've got 12 walruses and 12 walruses. Well, then I got 24 walruses. Now we combine our constant terms. 9, 8 is 17. 9, 8 is 17. 17 and 17 makes 34. See if you could come up with an expression for the area of that rectangle. When you think you've got an expression for the area, raise your hand.
Common sense.
All right, so when you're finding the area, here's the most common mistake I see people make. People go, well, here's my length and here's my width. So if I take length times width, they go like this. They go, well, 9 times 8 minus 12W, because they took this side times this side. And they go, well, 9 times 8, that's 72 minus 12W. The problem with that is you took 9 times the 8, but you have to take 9 times this entire side. Think of this side like a group of stuff. If you write it with parentheses, then you're going to remind yourself that you have to do the distributive property. 9 times 8 minus 12W. Well, what's 9 times 8? 9 times negative 12W. Negative 108W. Okay, last idea with the distributive property. This one's kind of just a slick trick. How can we use it to find prices? Like somebody says, you buy 4 hats at $5.02 a piece. Find the total cost. Without to bust out your cell phone and get the calculator going, how can you do that in your head? I mean, you should be able to...
$5 times 2 and then you add 2 cents.
Okay, think about distributive property. Think you've got 4 times, well, $5.02. I could write that as like $5 plus 2 cents, right?
Yeah.
Well, 4 times the $5 gives you 20 bucks. 4 times 2 cents is 8 cents. What's the total cost? $20.08. How about 8 tacos at $3.07 a taco? Who thinks that's an expensive taco? Maybe it's coming from Chipotle or something. How could you do mental math? Mental math, how could we do that lickety split? 8 times 3, that's going to be 24.
And then you do 8 times 27.
8 times 7 cents is going to be 56 cents. Bam, there we go. Didn't need a calculator, didn't have to get the cell phone out. Mental math. How about, this is a little different though, 6 hot dogs at $1.98 a piece. Ooh, 6 times 1 plus 6 times $1.98. I'm sorry, 6 times 1 plus 6 times 98 cents. That's tough. How else could you think about it?
Okay, so you could do 6 times $2 and then take 6, or then you like minus the 6.
Yeah, she's right. $1.98, she's saying, well, that's just $2 minus 2 cents. That's the same thing. So Kendra, what was 6 times $2?
12.
Minus how much do you have to chop off of that?
12 cents.
6 times 2 cents is 12 cents, so what's your total cost going to be?
11 cents. $11. 88 cents.
Awesome, okay. How about this last one? 9 cell phones at $9.95 a piece. They're on sale, huh?
Well, other than the kind of cell phones, all I had was the emergency in the home.
How could you calculate that cost just like that? Stuart, what do you think?
9 times 10.
Would be $90, but you're saving
What? 5 cents.
You're saving 5 cents per cell phone at 9 cell phones. So how much do you save?
40 cents.
45 cents. Well, what's $90 minus 45 cents?
80.
That's okay. Here's what I like to do. When I'm dealing with numbers like this, okay, I like to go like, Stuart, what's 1 minus 0.4?
1 minus 0.4 is 0.6.
Minus 5 cents. 60 cents minus 5 cents? 55 cents. Very good. Okay. All right, so this is kind of a slick trick using the distributive property idea.